and welcome to another lesson on functions. We are going to be focusing on something called inputs and outputs. And before we actually do that, we should actually talk about what we talked about in the previous lesson, which is what domain and range are. And I think some people are forgetting that which one is which, that domain is the x values and range is the y values. So there's actually a small little song I have for this. And if you ever wonder about domain and range, I want you to think about this song. All right. And here's how the song goes. Have you ever heard the song Home on the Range? You know, home, home on the range, where the deer and the antelope play. The song goes something like this. Y is the range, and X is the domain. I'll sing it one more time for you guys, because I know you love my singing voice. Y is the range, and X is the domain. All right, so remember, domain is like all the x values of a function. Range are all the y values that we're talking about. But going back to what input and output are, guys, inputs refer to domain because typically you put x into functions. Outputs are the final result, the range, which are the y values. So inputs, domain, same thing. Outputs, range, same thing. Let's take a few examples of this, okay? So here we have this situation. We have our x is the age of boys, and y is the corresponding height in inches. So it's like, think of this as like a situation where it's a data analysis of comparing age to height. So we have these sets of numbers here, and they might seem a bit confusing, these ordered pairs. So I can actually split them up into x and y, or inputs and outputs, or domain and range. So the first one is 7 and 41, 845, 949, 1052, 1053, 1155, and 1259. So we figured out yet, guys, that like this whole point of this lesson is for us to be able to represent these sets of numbers, these x's and these y's, as a bunch of different things. So I think you're all pretty familiar with tables and know how to set up the x and y's. And in fact, this next part you probably will find pretty simple too, right? Because you've all dealt with graphs before. But let's say I wanted to graph 741, right? I would look at the right here, the x-axis is x. I would go to 7, and I go all the way up to 41 right there. Put it nice and red. 8, if I were to graph that, it'd be 845, 9, 49. The next one is 1052, and we also have a 1053, so we have another dot right above it. See that? 52, 53, but they're both for someone who's 10 years old, an X. Then 11, 55, and then 12, 59. So we have these dots. We can see kind of a nice little linear relationship here. But notice how we're graphing these guys. We're looking at the x's first, and then we're going up to the y values and putting a dot right there. And so these are two things I think you guys should be very comfortable with. But what you might not be used to is something that's more of a mapping diagram. So here's a mapping diagram right here, guys. And what a mapping diagram is you put a nice big group of all the x values, or in this case, these are the ages, right? And we group all the y values, which are the heights. But you'll notice that we do not include any repeats. Notice how these are uneven? Remember that we had two 10s right here? So in mapping diagrams, you list out all the x's and all the y's, but you never list out a repeat. And the way you show that the 7 is connected to 41 is I'm going to draw an arrow that the 7-year-old has a height of 41 inches, because 741, that's what we started with, right? 845, 949, 1052. Now you're probably wondering, Mr. Porter, how do we do 1053? But we have the exact same input, right? So this would be 1053 right there. And then we have 1155. And then we have 1259. And then if I wanted to list out the domain, I would just list out these numbers here. And I would absolutely not do any repeats. And then for the range, I will list out all these right here. Now, here's the thing, guys. Despite us representing this relationship between age and height, this actually is not a function. And that's because of this situation right here. A function is something that for every input, there is one output. If you ever have an x value with two different outputs, 10 gave me a 52 and a 53, then it is not a function. Let's go ahead and see a bit more Let's go look a little more into that, okay, guys? So if we turn to page 117, you're going to see an example here where it's comparing gas to distance. And it's already done for us, right? So let's analyze this a bit further. We have a table, we have a mapping diagram, and we have a graph. If I wanted to list out the domain, honestly, you can look at any of these. Choose which one you like the most. Honestly, I like mapping diagrams the most because it doesn't count any repeats. So I have 10, 16, 17, and 20. This domain clearly represents the different amounts of gas, right? Well, look at the range. 150, 240, and 300. And this is why, guys, it's very important for us to never, ever have these repeats. Notice we have these two situations where gallons of gas, 16 gave us 240 distance and 17 gave us 240. Think about why this could have happened. Do you think maybe these are two types of cars and some car just gives you more mile per gallon? That's probably what happened, right? Or maybe they were driving at different speeds. Regardless, we know that, back to this trying to fill this information, the range represents the distance traveled. So with all this information here, we can actually answer these things right here, these fill in the blanks. It says for an input of 10 gallons of gas, guys, what's the distance? I'm going to use the graph this time. 10 gives me 150. How about an input of 16 gallons of gas? I'm going to look at the graph once more. 16. That gives me about 240 miles. 17, also 240. An input of 20 gallons of gas gave me about 300 miles. It's pretty good. So this relationship, because, guys, notice how every single input gave us a different output. It's okay that 16 gallons of gas and 70 gallons of gas both gave us 240 miles. That is acceptable. What's not acceptable is if 16 gallons of gas gave us 240 and then like 250. That wouldn't make any sense. So this relationship is a function, and each domain is paired with exactly one range value. 17 will always give us 240 miles based on this data. In the next lesson, I'm going to show you guys how you tell if something's a function or not based off its graph. But for now, make sure you guys do the homework. You have a good day. Bye.